content of my presentation is energy management control system and energy management system. Then energy planning and monitoring and so on. And I will not, you can read it, I will not repeat it. But what is energy management? The goal is to achieve and maintain operation energy procurement to minimize energy use and costs. When I was young engineer, more than 30 years ago, I deal with such topics. On the chart, which is from 1983, on this chart, you already can see the long-term planning, short-term planning, in real time the operative control, and then assessment of the operation. Something similar like ISO 50001 describe it. So what is the planning in long-term and short-term planning? Because of time shortage, I will not repeat it, but there is a homepage address we published with one colleagues from NASA Cleveland, an article, and you can read it. This is from 2002. You know conceptual flow of the energy management system, ISO 50001. As I thought, like to this, what we used and as a energy management control system. To this I would like to add, and since I would like to speak about the planning, what is very necessary in frame of planning, and then what is very necessary in frame of monitoring and analyzing or assist the operation. Certainly, the planning should be based on the detailed energy audit. It means at first to prepare a good audit, and then we can plan the energy saving and the operation of the system. And certainly it is very necessary analysis or assessment of the operation. You know this too, because it is from the standard ISO 50001. And something, when I read it, I thought that something is missing from this flow chart or from this planning. What is missing? What do you think? I think that what is necessary, and I would like to offer to add it, that certainly when we would like to plan energy planning or to do energy planning, we should do at first planning of production and or business plan. And based on it we can plan the energy consume and so on. I showed the conceptual scheme. This is the practical flow scheme of the energy management system. The planning cycle is here. What we will do, certainly, very is necessary energy politics. But, as I told, in my opinion, very is necessary is the detailed energy audit. Then feasibility study, then financial analyzing, you mentioned here already before. Then project proposal, and then realization, implementation. In the implementation cycle, if the first was the planning side, we should start energy management system to build based on the project plans, energy saving project prepare. Here will be the saving. Then we should do the internal audit and then evaluation, improvement of the planning or of the operation system. Analysis of past and present energy consumption. Possible methods are graphs, charts, tables, spreadsheets, and possible sources, meta reading, estimation, and so on. What we have done, as I told as example, on this slide you can see the energy consumption from 2010 until 2016, and when at the audit we get the data from the previous years, we are looking for that what depend in this is not shows. What happened in the factory? At the first years, I will not show because you cannot see. At the first year, you can see that there is increasing. Increasing is because the manufacturing expansion. But after the years, 2014, 5, there was already not increasing, not expanding manufacturing, but a bit increased production. Production is with the blue line. It is natural. It certainly with the developing, it increasing, manufacturing also. On the left side, you can see energy consumption in megawatt hours per annual, and the second, and the right side, you can see products in million pieces. So, when we would like to plan the production, what should be the baseline? We should take the increasing of the production or the average of the previous years. On this slide, you can look at the planning cycles for the 2016 and then the actual, because we prepared this slide for the presentation after the 2016 to show that how we can plan, do the planning, and then what was the result of the planning. It means baseline for the production should be what you can see, 0.95 million pieces, or the average from 14, 15. We decided the medium value to be a target value. And what was the result? It means the planning was based on the 14, 15. We decided what we will plan, and then the result was certainly not the planned. There is difference. You can see 0.22. This was the production planning. And then the electricity consumption. In the same way we planned it. And certainly, since electricity consumption depends from the manufacturing, how many pieces were produced, And then how we done the planning. The question was also that take the same amount of electricity like it was in 14 and 15, or some other. We decided that since we would like to save about 1.5% or increase the efficiency, then we decided that we in 2016 should consume not more than 8,635 megawatt hour annually. This was decided with the target in saving 1.5%. Since was produced more than was planned, we used a correction factor and calculated the based on the actual production, the energy consumption. And then we calculated the difference between it. And we, as a result, got that annually consumption of electricity was more than in plan. It means we should looking for possibility how to fine-tune the planning. Something similar we made for 2017. We don't know the result, but we made the planning for electricity consumption. In January, we will calculate what is the difference between planning and actual data. So, I would like to tell you that it is not easy to plan production than electricity consumption, but we should looking for the possibility. I will go through this because of time shortage. And certainly we are looking for how to fine-tune it. And here you can see the production and special consumption of the electricity for one pieces of production, or we should compare it and looking for to the other measurement. So I go through on this. On this chart you can see the monthly electricity consumption and planned electricity consumption expected. For 2017 plan, you can see and certainly since we were evaluated it after June, here we can see already the actual electricity consumption too. So this is to planning and evaluation. Identifying areas having a significant energy consumption. Possible technical issues and examples. It means energy aspect that must influence the energy, then analyze processes, plant, equipment, and so on. We are using Sankey diagrams, and in Europe, based on the directive, we should divide in three parts of the electricity or energy consumption. These parts are buildings, production, and transport. I cannot show with the laser pointer. And you can see already that on which part we should focus. Buildings, it is not so much, but production of chisel and drills and process cooling, quite a bit amount is. It means at first we should focus on these groups. We can look at the same in the chart, in the P diagram. It means from this we will select. On this slide you can see the monthly electricity consumption for heating, for cooling, with with heat pumps, monthly average outdoor temperature also. It means we can see that at the winter time, at the summertime, there is a difference. But in this case, because of we are using much energy for the cooling, in this plant is not used free cooling. It means this is a possibility to save energy with using free cooling. Monthly electricity consumption of heat pumps and monthly production we can see, and technology cooling certainly depending with the production. It means from this slide we can see that what we use for technology cooling and what is necessary for comfort cooling in the halls and in the buildings. So the next step as a tools identifying opportunities to improve energy performance, and this is divided in two groups, periodic and continuously. What we should do, it is better if you will read there before I go to the next slide. You can find this, my presentation, in written form too. You can download it from the website. You will get the address. To this I would like to give an example with the air compressors electricity consumption in monthly production and what we recommend when we have done the audits. The first step was only very similar, closed the valve after the production, and security guides should check it if the employers closed or not closed, and the result you can look at on the slide. And then when we notice that it is the very high pressure what they used, we know, or you know, that equipments need around 6 bar, and it is higher. We should looking for the possibility, what is the reason, it's really necessary or not. And they agreed that they will decrease the pressure. The result you can see on this slide 2. It means if we are looking for possibility, looking for long, we are looking for the possibility, it means that how can we, without investment cost, safe. These are with the pressurized air system. So, heat recovery, very necessary. In this case, we can looking for where we can get waste heat and where we can utilize it. I think that you know the pinch point analyzing. In these slides, you can see the theory. It means in case or in many technology processes, we use or we need to cool or to increase the temperature. If we are pushed together these diagrams, it means on the left side there is a heat flow and we need cooling for. If we are pushing together, then we can save a lot of energy, and in this case we can not use fossil fuels. As a topic I would like to tell you, here you can see on left side an engine, gas engine, Jembacher, the main sponsor of our conference. And on the right side, the absorption chiller. And you can, base data you can see on the slides too. And if we went there, certainly we used to read the data from the engine, from the, on the right side, from the absorption chiller, and we began to analyze the data. On this slide, you can look at or see engine with absorption chiller and base data. You can notice that here in this part, the exhaust gas out temperature is, or forward temperature is 170 degrees Celsius. It is too much to allow to go to the environment without using, if there is a need for heating. It means heat to be rejected is 6,451. Here also 1,020. Is there a possibility to use this waste heat? Certainly, it used to be, only we should find it. Here is the scheme for the heat exchanger from gas engines and absorption chiller. And here is the 170 degrees Celsius. How we can use it? You can look at it on this chart. It means if we have 170 degrees Celsius on top of the, yes, here, we can cool down, and we can use at first for the additional absorption chiller, we can use additional 200 kilowatts. For the heating, we can use additional kilowatts. Here it is 295, sorry, here we can use more than 400. And for domestic water, we can also use. It means total we can save almost from one engine 1 megawatts output. And when we are calculating in hourly amount, it is quite big amount. So, and what should we do? To put there additional 3 heat exchangers. So to the calculation, you know this system for calculation. I would like to show only one diagram for sensitivity analysis. They are base data, and we are estimating if from base data the energy price, the investments cost, or economic lifetime, or interest rate, minimal acceptable rate of return, if it is changing, how it is changing the acceptable investment cost. Here I show you how we can save energy with decreasing heat, a peak demand. And finally, as a summary, I would like to draw your attention to the plan, do, check, act cycle, or Deming cycle, that we should improve in processes in frame of ISO 50001, the possibilities, and looking for possibilities how to